Everything today is going to be about cross multiplication. Again, you call it the butterfly method. It's cross multiply. You make these diagonal bubbles. You multiply inside the diagonal. 4 times 6 is 24. 3 times x is 3. We divide by whatever number is smack dab up against the variable. So I divide both sides by 3. X equals 8. In here, we are going to draw our bubbles. In that bubble, I have 20 times 1. Then I put an equal sign. In my other bubble, I have 10 times x. I now have an equation that I can solve. 20 times 1 is 20 equals 10 times x is simply 10x. What do I need to divide it by? Tyler?
10.
10. On this side, all we're doing is just getting the x by itself. The key is knowing 20 divided by 10. How many times does 10 go into 20, Lauren? 2. So x equals 2. Now watch what happens. 1/2, because that's what x is 2. So 1 over 2 is the same as 10 over 20. Is that true? If I simplified 10 over 20, it would be 1/2. Proportions are fractions that are equivalent or the same. Over here, I multiply 4 times x. I put an equals. I do my other diagonal. 12 times 5. Can we multiply these? Well, yeah, 4 times x is 4x. Equals. A little bit tougher. 12 times 5 is 60. What number am I dividing by, Cole?
4.
You know what, Cole? Come on, Cole, you know what? You're the man. We're dividing by 4. That leaves me with x equals. If you don't know how many times 4 goes into 60, use long division. 4 goes into 6 once. 1 times 4 is 4. That's 2. The 0 comes down. 4 goes into 25 times. No remainder. Gives me x equals 15. Questions on cross multiplication. Again, you've called it the butterfly method. And Miss Armstrong, we've been doing it since at least 4th grade, the butterfly method? Yeah.
Probably 3rd grade.
Okay. And Mrs. Armstrong, just for the video, what grade did you teach before this?
4th grade.
Oh, so you actually know that it was taught in 4th grade.
I know that it was taught in 4th grade.
Me too now. So no excuses. Get out a piece of notebook paper for you to copy notes on.
You use the same paper.
This is the last day of notes. So we are on scale drawings day 4. Today we are talking about similar figures. We are talking about similar figures. First, this is absolutely not the geometric definition of similar figures because you don't know enough for me to go into detail about proportionality and talking about similar figures. So we're going to keep it to our scale drawings. Similar figures are dilations. That's it. A dilation is either enlarged or reduced by the same scale factor. So similar figures are dilations. They are either bigger or smaller figures from an original. That's all. They're either bigger or smaller than an original. Kind of like what we've been doing. We have a pre-image, we have an image. But really, similar figures, all the sides are proportional. It means they're proportionality. Blah, blah, blah. Listen! All we're going to do is know that they are the same as dilations. We're going to be matching up corresponding sides. We're going to be doing all kinds of good things. I promise you, nothing is hard today. Today is probably the easiest day of the whole thing. It says they are either bigger or smaller figures from an original. If I asked you right now, how do we find the scale factor? What is that division that we have to do to find the scale factor? And this shouldn't be something that we don't know because we've been doing it for our warm-ups for several days. Image divided by pre-image. Very good. Image divided by pre-image. That's how we find the scale factor. Today, when we set up fractions, we are always going to go image over pre-image because I want that to be drilled into our heads. Drailed. I was going to say, I don't know what I was going to say. You stop it, Mrs. Armstrong. Drail. Yep, there goes my accent, my country accent. Here we go. So, these are the types of questions you're going to see. Solve for the missing side of the similar figures. Okay, so we're going to solve for a missing side. Trust me, you're going to be able to do this. And you're going to be like, Mr. H, why didn't we start with this? So you're going to have this triangle, 6, 10. Then you're going to have this triangle. Woo-hoo. And it's going to say 12 and X. Already, some of you probably know the answer, which is great. Which one is my pre-image? Which triangle will be my pre-image? The 6 and the 10. This triangle is my pre-image. Every single thing that we've done has gone, the left figure is my pre-image, the right figure is my image. That's not going to change. Pre-image, image. Are we good? Okay. Give me a fraction. Give me a fraction. Go ahead, Braden. 12 over 6. 12 corresponds to 6. Those are in the same place. Does everybody agree with that? That 12, which is on the left side of the triangle, corresponds to 6, which is in the same place on the left-hand side. So we went from the right triangle, image, to pre-image. We need a proportion. So I still need another fraction. What will my fraction be, Macy? X, which is in my image, divided by the pre-image, which is 10. Now I have a proportion.
So if you guys notice too, we're putting the corresponding sides, the 12 and the
It's always image
yeah,
over the pre-image.
but it's the corresponding side too, if you notice that. So it's like the 12 is a corresponding side to the 6, just like we've done before. The X is a corresponding side to the 10, okay?
You guys with that? Okay. These have to be the same. What I mean by that is, when we multiply, when we solve, if we simplified, they'd have the same scale factor. So, we are going to cross multiply. When we cross multiply, I make my bubbles. I'm going to want to see your bubbles on your sheet. That gives me 6 times X equals. Draw your other bubble. And some of you are absolutely not doing anything right now. That's disappointing. That gives me 12 times 10. We're going to solve this equation for X. So 6 times X is 6 X's equals 12 times 10 is 120. We're not done solving yet because we have a number next to the X. What do I need to divide by, Tyler? Or Mason, sorry.
120 divided by 6.
Good. We're going to divide it by 6. That leaves me with x equals,
20.
it's going to be 20. But let's say we don't know that it's going to be 20. We're going to use long division. 6 goes into 12 twice. 2 times 6 is 12. That leaves me with nothing. Bring down the other 0. 6 goes into 0. 0 times. No remainder. X does equal 20. Now let's say I asked you a silly question now. What is the scale factor? Braden, what do you think?
2.
How did you get 2?
Because 12 over 6, if you divide 6 into 12.
So if you divided these by 6, you're telling me that gives me 2 over 1, right? Well, if I also had 20 over 10, I could divide both by 10, which gives me a scale factor of 2 over 1. I knew, because 6 times 2 is 12, 10 times 2 is 20, the scale factors are the same. Everybody with me still? Can we try another one? Yeah, you don't really have a choice. You can say no, but then you'd have to take the test and you'd only have one example, and that'd be a mistake. It doesn't have to be a normal figure. They don't have to be normal figures. It could be something like this. I could have 15 and 12. And 3, and 5 and x. The first thing that we need to do to set this up is form a proportion. Michaela, are you ready? How ready are you? Ready, good, okay. Michaela, which figure is my image? The right one, okay. Set me up a proportion, Michaela. Okay, let's stop there. Michaela said 5 over 15, which is exactly correct because those are corresponding parts. 5 is on the top side, 15 is on the top side. So far, I love it, Michaela. Equals.
X over 12.
Again, image over pre-image. X is on the bottom, 12 is on the bottom. Michaela, that is brilliant. Okay, corresponding parts. 5 matches up with 15. X matches up with 12. Notice we went image over pre-image. Now we are multiplying. Okay, Cole, you ready to be the man again? You want Owen to be the man? Owen, you're going to be the man. Owen, we're going to multiply. That gives me 15 times x equals. What else do I have to multiply?
5 times 12.
Very good. 5 times 12. So I'm going to say 12 times 5. Am I done right there? No. 15 times x is 15x equals. What is 12 times 5, T? Oh man, you're on the spot. Don't worry, you're on a video too. Don't screw it up. No pressure. What?
No, hold on.
Okay.
7.
Try again. Let me know when I can hold on.
Okay.
Let you know when you can let go.
Well, I'm holding on. I got this board, I got this wall, I'm ready. 60, can I let go now?
Yeah.
Okay, shoo, I don't have to hold on anymore. It is 60. Now, what do I need to do to get x? Jason, what do I need to do?
Divide it by itself, right?
Divide what by itself?
X by itself.
Not quite.
15 by itself.
Yeah, I'm going to divide it by 15. When I divide it by 15, that leaves me with x. 60 divided by 15 is?
4.
4. Good. So now x equals 4. Who thinks they know what the scale factor is? Ma'am?
Scale factor's 3,
Is it an enlargement or a reduction?
reduction.
So can the scale factor be 3?
No, because that's bigger than 1.
Yeah. So look at how we have it written. It's 5 over 15. And then if x equals 4, it would be 4 over 12. So what's the scale factor if we reduce those?
1 over 3.
Very good. The scale factor then of these is 1 to 3. Very good. Okay, you got one more. You guys need to raise your hands when you have the proportion. Once we've said the proportion is A-OK, then you can start to do the problem. Does everybody hear that? You're going to copy it down. You're going to raise your hand. One of the 4 of us. There's 4 of us in here. We'll check your proportion. Then we'll say, okay, keep on going. Go. Set up the proportion first. You're going to need to copy it down. You're solving for x. You have to set up the proportion before you can go on. Go.
No, so it's, is it this one you're doing? So it's image over pre-image. So this, so it'd be x over 16. So you weren't wrong, you just don't have those in the right order.
Where's my proportion? Where's the proportion?
Jason should, yeah, you're good.
Good. Good.
Yes.
So once you have the
Did you set up
proportion,
your proportion?
we'll let you know whether you can go on or not.
I really don't know. So what does your proportion look like? Okay, so there's 16.
Very good. So, what is the proportion?
Oh, well, that's not a 2, that's a 3. Yeah, so put that needs to be a 3 right here. There you go. There. Okay. Do it.
Armstrong.
I hear you, it's not right there. I'm one, so you're X over 16.
Yes, that is correct. Nice one. What you have there, sir?
You don't need to find the scale factor. You did exactly what you're supposed to do.
Okay, what did you solve for? Well, where is your?
Okay, hey, really
Okay.
pleased. Most of you did
16
wonderfully.
is 48, is that what you got?
Which is
Okay.
the image. Sheldon, is this the image? Or is this the image?
And what are you gonna divide by?
The left one is the image. So if this isn't the image, what do we call this one?
So what is X equal?
Yeah. The left will always be the pre-image in
Yeah,
this
put
class.
equal sign in between.
So I'm setting up a
Because what?
proportion. What corresponds to x, Sheldon? What matches up with x in my other rectangle?
16.
Good. So I have x over 16. Those match up. Olivia, what's going to be my other fraction?
3 over 12.
Very good. So we're there. Now we are going to cross multiply. So now I have 16 times 3 equals 12 times x. 16 times 3, that's 18, carry the 1, that's 48. So now I have 48 equals 12x. divide both sides by 12, x equals 4. Now, that's all this question was asking, but somebody said, Mr. H, I don't know how to find the scale factor. Now that we have x equaling 4, if I wanted to find the scale factor, it's image over pre-image. So it's going to be 4 over 16. Divide both by 4, gives me 1/4. That works, but what other one do I need to check? If I did 4 over 16, what else do I need to check, Tyler? So I did 4 over 16. What's the other?
12 over 3.
Which one?
3 over 12.
3 over 12. And I can divide each by 3. That gives me 1 over 4. Because they're exactly the same, it's a dilation, or in this case, a similar figure. And the scale factor is 1/4. Does that work? Did my figure get reduced? Is it a reduction? Yeah. So the scale factor can be 1/4. Questions there? It's all about multiplying and setting up proportions.